Welcome to the Science, Technology, and Society Lectures. In this video, we will talk about science, technology, and nation building, including the Philippine government science and technology agenda, and of course, the major development programs and personalities in science, technology in the Philippines. For us to understand how science and technology began to thrive in the country, let's know first about the brief history of science and technology in the Philippines. Science and technology during the pre-colonial period was limited to the use of herbal medicines, and only farming, fishing, mining, and weaving were the first livelihood skills developed by the Filipinos. One great evidence of the farming skills of early Filipinos is the breathtaking Banawe rice terraces of Ifugao, which was developed for livelihood purposes. Technology is used by people in building houses, irrigations, and in developing tools that they can use in everyday life, and it is evident in the excavated stone flakes used as tools and weapons, and even in sawing and polishing other stones for other purposes such as hunting, cooking, and fishing. Later on, ornament of seashells and pottery were developed together with metal tools and ornaments until the importation of cast iron from China. They also learned to build boats for trading purposes, like the plank-built warships called caracoa, suited for the inner island trades. Spaniards even utilized Filipino expertise in boat making and seamanship to fight rival groups and countries. When the Spaniards colonized the country, they brought with them their own culture and practices. They established schools for boys and girls where they focused on learning science and understanding different concepts related to the human body, plants, animals, and heavenly bodies. During this time, Philippines became modernized due to the adaptation of some Western technology and their ways of life that even advanced methods of agriculture were taught to the natives. Moreover, the galleon trade and the opening of the Suez Canal brought opportunity for Filipinos to study in Europe and get influenced by the rapid development of scientific ideals brought about by the Age of Enlightenment. Finally, on the later part of the 16th century, more schools were developed which opened more opportunities for Filipinos to learn science and to ignite their curiosity towards the world. In contrast, the Americans had more influence in the development of science and technology in the Philippines. There were simultaneous government encouragement and support for an extensive public education system. Science research agencies were built to give science-based public services. The Bureau of Public Works was created, and by that time, the Americans found out that there were no competent Filipino engineers, so American engineers had to be imported. From then on, special efforts were made to attract Filipinos to pursue advanced studies leading to careers as engineers. Upon achieving their professional qualifications, they were employed as junior engineers in the Bureau of Public Works. The University of the Philippines was established and remained the only publicly supported institution for higher education. The Bureau of Government Laboratories and the National Research Council of the Philippines were also established. Even the study of tropical diseases and production of vaccines have been dealt with, and there were researches done to control malaria, cholera, and tuberculosis and other tropical diseases. However, with these advances that the Philippines had during pre-colonial, Spanish, and American regimes, the country had a difficult time to rebuild itself from the ruins of the war. Through the help of Japan, reparation funds focused on building some institutions and public facilities like schools, hospitals, and transportation systems. Since the establishment of the new republic, the whole nation has been focusing on using its limited resources in improving the science and technology capability in the country. Compared then, we are lucky nowadays that our government is extending their support in developing science and technology to create an avenue for researches and inventions that will help our country grow. Before, science and technology has limited its resources of what is existing, but now science and technology had improved and is expanding its means for new studies and relevance. This is because the goal of the government is to prepare the whole country and its people to meet the demands of a technologically driven world and capacitate the people to live in a world driven by science. As reported, the Department of Science and Technology, DOST, has sought the expertise of the National Research Council of the Philippines to consult various sectors in the society to study how the Philippines can prepare itself in meeting the ASEAN 2015 goals. As a result, the NCRP has been expected to recommend policies and programs that will improve the competitiveness of the Philippines in the ASEAN region. Therefore, the NCRP clustered 4 policies, namely social sciences, humanities, education, international policies and governance, physics, engineering and industrial research, earth and space sciences and mathematics, medical, chemical and pharmaceutical sciences, and biological sciences, agriculture and forestry. The first policy is focused on the improvement of education and the welfare of the society. It includes integrating ASEAN awareness in basic education without adding to the curriculum, emphasizing teaching in the mother tongue, developing school infrastructure and providing for ICT broadband, and of course, local food security. The second policy is focused on emphasizing degrees, licenses, and employment opportunities, outright grants for peer mentoring or the funding provisions for researchers, the review of RA 9184 or the Government Procurement Reform Act, and harnessing science and technology as an independent mover of development. The third policy works in ensuring compliance of drug manufacturing firms with ASEAN harmonized standards by full implementation of the Food and Drug Administration, creating an education council dedicated to standardization of pharmaceutical services and care, empowering food and drug agencies to conduct evidence-based research as pool of information, and allocating 2% of the GDP to research, and finally legislating a law supporting human genome projects. The fourth policy is focused on protecting and conserving biodiversity by full implementation of existing laws, the use of biosafety and standard model by ASEAN countries, promoting indigenous knowledge systems including indigenous people conservation, and formulation of common food and safety standards. There were also some government-supported programs through DOST, which are as follows. The funding provisions for basic research and patents related to science and technology, scholarships for undergraduate and graduate studies of students in the field of science and technology, establishing more branches of the Philippine Science High School system for training young Filipinos in the field of science and technology, like the Manila Science High School and the Philippine Science High School, creating science and technology parks to encourage academe and industry partnerships, the Balik Scientist program to encourage Filipino scientists abroad to come home and work in the Philippines or conduct research and projects in collaboration with Philippine-based scientists, and the establishment of National Science Complex and National Engineering Complex within the University of the Philippines, Diliman. Meanwhile, the Philippine-American Academy of Science and Engineering, or the PAASE, also identified several capacity-building programs such as establishment of national centers of excellence, manpower and institutional development programs such as engineering and science education program to produce more PhD graduates in science and engineering, the establishment of regional centers to support specific industries that will lead the country in different research and development areas, the establishment of science and technology business centers to assist, advise, and incubate technopreneurship ventures. And lastly, to strengthen science education at an early stage through the Philippine Science High School system. Now let's talk about the major development programs by the different presidents of the Republic of the Philippines over the years and meet some of the brains of the country who contributed in the field of science. Ferdinand Marcos mandated the Department of Education and Culture, now DepEd, to promote science courses in public high schools. He allocated additional budget for research and even donated war damage funds to private universities to encourage them to create courses in science and technology and dig into research. In his long years of service, the following were also among the organizations established: the Philippine Atmospheric, Geophysical, and Astronomical Services Administration, or PAASE, the Philippine National Oil Company, the International Rice Research Institute, the Philippine Coconut Research Institute, and the Philippine Council for Agriculture and Fisheries. During Corazon Aquino's regime, National Science and Technology, or NSTA, was renamed to Department of Science and Technology, or DOST. She also came up with Science and Technology Master Plan to update the production sector, improve research activities, and develop infrastructures for science and technology sector. After her was Fidel V. Ramos, and during his time, the Philippines had approximately 3,000 competent scientists and engineers. He approved laws including RA 8439, or the Magna Carta for scientists, engineers, researchers, and other science and technology in the government, and RA 7459, the Inventors and Inventions Incentive Act, to promote and encourage the creation and manufacture of Philippine invention. The RA 8293, or the Intellectual Property Code of the Philippines, to give people and business property the right to the information and intellectual goods they create, and of course, the Doctors to the Barrio program that made healthcare accessible in far-flung areas in the country. In only half of his term as the president, Joseph Estrada was able to approve the RA 8749, or the Philippine Clean Air Act of 1999, the Comprehensive Air Quality Management Policy and Program, which aims to achieve and maintain healthy air for Filipinos, and the RA 8792, or the Electronic Commerce Act of 2000, providing for the recognition and use of electronic, commercial, and non-commercial transactions. When Gloria Macapagal Arroyo assumed the office, she launched a drive to encourage technological innovation, which was coined as Philippinovation, to refer to the Philippines as an innovation hub in Asia, and also approved RA 9367, or the Biofuels Act, to utilize indigenous materials as resources or sources of energy. While there were not much scientific programs and laws made during his government, Benigno Aquino III named some new scientists, and they are Gavino Trono, who made extensive studies on seaweed species, which helped families in the coastal populations; Angel Alcala, who made major contributions to marine biology research efforts in the Philippines; Ramon Barba, who studied the induction of flowering of mango and micropropagation of important crop species, and Edgardo Gomez, who led the first national-scale assessment of damaged coral reefs, which led to a national conservation program such as replanting corals. The current administration of Rodrigo Duterte, through the Philippine Space Technology Program, launched Diwata-2 in 2018 after the launch of Diwata-1 in 2016 that displayed the Philippine flag in space. Also, RA 11305, an act institutionalizing the Balik Scientist Program, was signed into law by the President on June 15, 2018. This law aimed to give more incentives to returning Filipino experts, scientists, inventors, and engineers who would share expertise. Moreover, 271 new weather stations were installed by the Department of Science and Technology throughout the country. School science is filled with names of foreign scientists, and we seldom hear of Filipino scientists being discussed in science classes. So, here are some of them. Abelardo Aguilar helped in the invention of the antibiotic erythromycin from a strain of bacterium called Streptomyces erythraeus. Gregorio Zara invented the videophone, or a two-way television patented as a photo signal separator network. Fabian Dairit made a contribution for his research on herbal medicine, and the very familiar Diosdado Banatao, a Cagayano, who is most known for introducing the first single-chip graphical user interface, or GUI accelerator, that made computers work faster, and for helping develop Ethernet controller chip that made Internet possible. Daniel Dingel, the inventor of water-powered car in 1969, is also included on the list. His hydrogen reactor uses electricity to transform ordinary tap water with salt into deuterium oxide or heavy water. Gregory Ligot Tangonan was also credited for his research in the field of communications and technology. Fe del Mundo invented the incubator. An incubator is an apparatus used to maintain environmental conditions suitable for newborn babies. And of course, Lourdes Cruz was also noted for her research on sea snail venom. There are also other scientists in the Philippines who are not identified on the list. Yet, the Philippines still need more scientists and engineers, and there is still a need to support scientific research in the country. Who knows? Soon, you will be included on that list for excelling in your own field. Keep going and keep dreaming.